Hello, students and parents. My name is Jane Feugel, and I would like to welcome you to my tutoring. In this video, you will have a glimpse of how I teach online, the tools I use to make lessons interactive and effective, and a sample mini lesson so you can see my teaching style in action. So I usually use Zoom, and right now, you are in the lesson about the special cases of the right triangles. I believe it's actually a very important topic. Students learn this in geometry and then use it in Algebra 2, in pre-calc. So the first case is 45-45-90 case, and it belongs to the isosceles right triangle. So if you see 45 and 45, it's 45-45-90 case. Not always. For example, if only one 45-degree angle is given, it's still 45-45-90 case because there is effect that sum of all angles in the triangle is 180 degrees. So if one of them is 90, another one is 45, there is only 45 degree left here. So it can be given to you like this. Or I can actually remove at all 45 and 45 and just leave these 2 marks like this. So these 2 marks means that these 2 sides are equal. This is isosceles right triangle, and therefore base angle should be the same. And again, if 180 degrees total, 90 degrees here, there is only 90 degrees for each of them. They're equal, so it should be 45 and 45. I'm going to erase all the marks right now. I will put back 45 and 45. But this is how you can see it, and you have to be able to recognize it. So 45 here, 45 here, we have 45, 45, 90 case. So in this triangle, we are going to have 2 legs. So the legs, they make 90-degree angle. So this is leg and this is leg because they're the same one. And very important to recognize hypotenuse, which is the leftover third side. But for my students, I usually tell them this, that hypotenuse you always find across from 90-degree angles. That's actually very important because sometimes pictures can be complicated. And if you look across, you will see hypotenuse from 90 degrees. Now, there is a relationship between the legs and the hypotenuse. So if you're going to measure, let's say I'm going to measure this leg, right? And then I will compare this leg to the hypotenuse, something like this, right? You can see that this leg smaller, hypotenuse is bigger. How much bigger? No, it's bigger. And there is actually one standard number. The hypotenuse is actually this leg times square root of 2. So it's bigger by square root of 2. By square root of 2, if I was your teacher, I would derive it for you. I would show you where it comes from. But so far, this is the relationship. Hypotenuse is bigger by square root of 2. So if you know the leg, you can multiply by square root of 2 to get to the hypotenuse. So this is right here. This is the formula. There is only one formula. And I would like to show you with some numbers. So let's say I'm going to give you this side to be 5, and I want you to find everything else. You can say, Miss Fogel, it's easy. It's 45, 45, 90 case, so these 2 legs are the same, and therefore this must be 5. Hypotenuse, which is across from 90, is always the leg, which is 5 in this case, and times the number, which is always square root of 2. 5 times square root of 2 is just 5 radical 2. If you want to see the approximation, you just take the calculator, type 5 times square root of 2, you will receive the number a little bit more than 7. But why would we do that if math likes exact answers? So this is the perfect answer for the hypotenuse. No, so again, to get from here, from this leg to the hypotenuse, we multiply by square root of 2. But if I want to go back, if I have, for example, hypotenuse, and I would like to see the leg, I have to do the opposite. I have to divide by square root of 2. So let me erase that. And let me give you an example how to do it. Let's say I'm going to give you, you know what, hypotenuse is 6, right? So to get to the leg, I have to divide by square root of 2. So if we multiply by square root of 2 to get here, to go backward, we have to divide by square root of 2. By the way, it's not the only way to teach this. There are different ways to do it. It's just, I had a very difficult class, and their skills were very low, and this, what they understood, not the formula. So basically I tried to, no, there is a formula here, but I wanted to see it more visual, like this. So if we take this, divide by square root of 2, then this thing here is 6 over radical 2. It's just simple like this. And this one, by the way, 6 over radical 2. So there is only one small issue here, and that 6 over radical 2, in math, we cannot have denominator that has a radical in it. That's why if I have 6 over radical 2, let me just write it down here, 6 over radical 2, we have to do a little bit more work. It's called rationalizing the denominator. And of course, for this kind of material, you need to know radicals. So again, if I would teach you, I would make sure that you know how to operate with radicals first. So we would multiply by square root of 2 top and bottom to get rid of the radical, right? And we are going to receive square root of 2 times square root of 2 is just square root of 4, which is just 2. On the top, we cannot multiply 6 times radical 2 because they're kind of not friends. I call them friends. So like number and radical, they're different. So I just copy down 6 radical 2. And there is one small thing what we can do. We can see that 2 goes into 6 3 times. And the answer should be 3 radical 2. So this expression here is actually 3 radical 2, looks a little bit better. And this is the same thing, 3 radical 2, and we found the sides. Again, I just wanted you to see how I work. So I hope that this video gives you a clear idea of what to expect from our tutoring sessions. And thank you for the watching, and I'm looking forward to working with you.